The Dulcoflow, some of the things it gives us are methods of keeping track of flow. Also with the control module on the Delta pump, that allows us to really control flow very precisely. The Delta pump can control the flow rate to a set point. If we say we want a certain flow out of the pump, and for some reason that flow rate is changing out of the pump, it can adjust the speed of the pump to get back to where we're trying to maintain. So that is a very nice feature. We'll go over the ident code of the Dulcoflow. We'll talk about which output we want to choose when in that ident code. The counter output as an input to the totalizer. So we have some other products that we can take the signal out of the Dulcoflow and totalize in those other products as well. We'll talk briefly about that just as an overview. And then we'll also talk about some installation tips and requirements. This particular device is very sensitive, so the way we install it is very important to the operation of that device. Some of the other devices that keep track of flow, you see a mass flow meter at the top left there. It's very expensive. It's limited on some of the materials that it's made from, so it's not always the best option. It will display typically an instantaneous as well as a totalized flow. Instantaneous is the flow rate that we're pumping at as far as a volume over time, and then the totalized flow is how much flow we've pumped or how much volume we've pumped since we started that count. Top middle is just a little paddle wheel flow sensor. It's very appropriate for us for some applications. That's typically for an instantaneous flow rate. We need another device to connect that to really be able to totalize it or even display that instantaneous flow. What we use now on some of the pumps is kind of that top right display. We use another manufacturer for that, and we get a totalized flow into some of our boiler and cooling tower controls. So we could potentially replace that with the Dulcoflow in the future. That also gives us a nice local display where we don't have that on that current device we're using. Just below that, a water meter. That's just totalizing. It's not really giving you an instantaneous flow rate typically. Calibration columns, we're all familiar with those. That's how we're calculating a flow rate out of the pump. But we usually have to do a drawdown and then do a calculation to be able to determine what the flow rate actually is. If that flow rate changes, that calibration column is not indicating that to us unless we set that back up and have to do that calibration. Thermal flow rate unit in the center, that's IFM effector, I believe. To the left of that, just a paddle wheel, inline paddle wheel, and then to the far left on the bottom is a rotometer. So that's going to give us also an instantaneous display. So we have a variety of ways of doing that. We're adding the Dulcoflow to do that. The way the Dulcoflow works, you'll see that the flow comes in from the left and flows out to the right. So we have flow going in one direction through that. At the same time, it's putting a signal through that flow in both directions. So obviously the signal that's going with the flow is going to transmit to the other end a little bit faster than the signal going in the opposite direction of flow. So from that and from the volume, the cross section, it knows the volume. It can calculate our flow rate through that device. So now we know our instantaneous flow rate. From the instantaneous flow rate, now it can keep track of, it can display that instantaneous as well as start totalizing how much flow is gone through. The ident code, some of the things we have to be careful of choosing. Of course, the second selection there is the 05 or the 08, but we consider DFMA being our first selection. That's going to go with what pump we choose. Okay, so we have to be very careful and choose the right one. Still picking that particular model doesn't mean we have the full range of operation. We have to watch where we're setting on the stroke length, so we have enough flow going through the device. The device does like to see that pulsing type flow, which is good because that's the flow that our pump is creating. So we have to be sure that we install it prior to the pulsation dampener. It actually needs to see that pulse going through. Most of the other selections are pretty much standard according to pump data or system data, as far as the tubing size we're going to use with it, the electrical connection. When we get to the signal output, we'll talk about how we're going to connect that or what we're going to use it for. So you can see if it's going just to a display, some sort of a display, you see a current meter on the right-hand side showing that 4 to 20 output. That can be scaled. A lot of digital units now can be scaled to show flow remotely. So if someone wants that remote display, we can transmit that. It's a powered loop that we're sending out. They do not have to series power onto that loop. In fact, if they series power onto that loop, they're going to burn that output circuit. So don't do that. But we can have that remote display as well as the local display right on front of the door. The counter output, that verbiage is what we want to see if we want the key connector, just like we have on the left-hand side on our flow control, our metering monitor device. So item or option 3, it combines the current output with the counter output. So it gives us that pulsing output as well as a milliamp output. Option 4, you see right below there, we can have that feedback. As we mentioned, it can go back to the Delta pump that has the control module in it. With that control module, we can set a set point of how much flow we want, and it's going to speed up or slow down the pump on its own to maintain that flow rate. So you see the device at the top. It's kind of difficult to see on that display, but if you look at the loop going off to the right, it's showing that it's measuring 5.6. But if you see the display on the front of the Delta pump, it's looking to maintain 5.4 liters per hour. So in this case, when that feedback signal comes back to the Delta is going to slow itself down to go back to the 5.4 liters per hour the system needs required. So we can have very precise controlled flow from that with the Delta. We talked briefly about the competitive device that we're using now on the left-hand side. Now we can switch that out to the Dulcoflow, and we can use that as an input to our boiler and cooling tower unit. So where they're trying to keep track of the amount of chemical that we're feeding, we can set that up. This is just an outline of the programming steps that we would have to take in the Dulcoflow to set that up. Typically, the multiflex and the Aegis want to see 1 milliliter per pulse coming into it. So we can set that up, program it in the Dulcoflow. For every milliliter that goes through, it gives 1 pulse out, which is now the input to those boiler and cooling towers. So keeping good track of the chemical for the vent. As we mentioned, it is important how we set this up, how we go about plumbing it. Of course, if it's going to be on a skid, we're going to take good care that it is plumbed in properly. To get it loose in a box, there's some things that you have to be sure that are done so that it does function properly. You'll see that the pump, item 7, is situated below Dulcoflow, pretty much directly in line. It's always best to keep that in line. It needs to be 20 to 30 centimeters from the Dulcoflow. So not too far, but not too close. That translates to 8 to 12 inches for us. That's where that pulse is ideal for the Dulcoflow to use that flow going through, that pulsing flow. And again, it's before the pulsation dampener, which is again in line with the output of the pump as always. Before the gauge and before the injection valve. We also want to regulate the back pressure. Back pressure changing can change flows going through the unit. We have found that about 40 psi minimum is an ideal pressure for the Dulcoflow. So you can exceed that, that's not a problem, but we want to regulate it to a minimum of 40 psi in most cases. We can work some applications below that, but we would have to take extra care and trial that before we commit to it. So just be careful. Again, we want to regulate the back pressure. When we regulate the back pressure, you see that M6 is now a pressure relief valve. So always take that extra safety step. Okay. So that's it for the slide presentation. We're going to move on to part going through the menus. So we're going to look at the video on this. Hopefully everyone can see the screen there. We're going to go through those menus now. Just like most of our other products, to access the menus, if you press and hold the P key for a few seconds, the menus will display. The first selection that we have is the mode. So if we select the mode, now we can select if the Dulcoflow is going to measure a volume or if it's going to display a mass. In either case, it's truly measuring volume. On mass, we would have to tell the unit the density of whatever is flowing through it, and now it can calculate the mass going through the unit. I think in most cases, it's going to be volume. So we're going to stick with volume and continue through the menus. Now we get back to the home screen, if you will. At the top, that line labeled V is a totalized flow, and the line labeled Q is an instantaneous flow measurement. So once we do some further setup, it's going to start displaying those as we have volume going through it. We go to the setup. In the setup menu, we can pick the display, current output, scale that current output, do some service. On the display, we can pick what unit of measurement we want it displayed in. Liters, minutes, gallons, milliliters, and we're back to liters. We're going to leave it in liters just for this. So the flow unit as well, you can have it in gallons per day, gallons per hour, milliliters per minute, milliliters per hour, and we're going to leave it at liters per hour for the demonstration. We have a dampening flow. This is kind of an averaging the flow going through it in a sense for the display purposes. So if that is changing too quickly, we would increase this number. 40 tends to be a fairly good number for us. So we're back to our main display. But one other thing we would have to do would be to go to calibration. When we go to calibration, we're going to do it either off of the stroke feedback, the quantity, and most often, I think, especially on our skids, the best way to practice that is to do it off of quantity. So typically our skids have a calibration column on them. We set them up and we can do a drawdown, and then we put in the volume that we drew down essentially. So we'll go through that, just kind of mocking it here. So we'll go off of quantity. We can do in quantity, we can do from correcting factor, but most often we're going to actually do the measured value. So we're going to go into measured value. We're going to start our pump. I've already primed the pump. So we're just going to let flow go through. Right now, the red light is flashing during this routine for us. You'll see that since we're in liters, the rate at which it advances is a little bit slower, but we're going to leave it go out. So the longer we let this run, the more accurate our calibration becomes. If we're off by a little bit in our drawdown measurement, you know, that can throw off the reading pretty significantly if we do it in too short a time period. So if we only drew down 10 milliliters and we were off by 1 milliliter, we're off by 10%. It's pretty significant. If we let it draw down 100 milliliters, we're off by 1, we're only off by 1%. So the longer we let this run, the more accurate that calibration is going to be. Okay, so now we press the stop on the pump, and we advance through the process. So now it's asking you, is that what you actually drew down? So now we have to take our reading off of our calibration column, and we have to calculate that into the unit of measurement that we're dealing with. So typically on that calibration column, we have to draw down in milliliters, and then we convert it to either gallons. So we would have to divide the milliliters by 3785. There's 3,785 milliliters in a gallon. Or we would divide it by 1,000. There's 1,000 milliliters in a liter to get to the liter setting. So we're going to agree with what it measured. We didn't actually draw down in a calibration column for the simulation here. So we're going to press P. You're going to show the correction factor at 94.21. We're going to accept that. Press P again. So now the unit is calibrated. When I start the pump again, now it's going to start displaying an instantaneous flow rate, and it's also going to start to totalize. We have some air in the line to prime out. So on the right-hand side, we're seeing the red LED on it. If we are feeding back to the pump for a metering monitor for the flow control signal, and we have that keyed connector plugged back into the front of the pump, we set the upper limit and lower limit, how far we're off. That means we're expecting to see a certain volume per stroke. And if we go below that volume, we want the unit to not count that as a stroke. Or if we go above that percentage off of that volume, we don't want it to be counted as a stroke as well. Then the pump will do the rest of the work. It starts counting the number of consecutive strokes without feedback from the Dulcoflow. And that can be up to 125 consecutive, and it would put the pump into a fault. Now we have to alert the customer with a relay output of the pump. Okay. So that's the basic overview of the Dulcoflow. Hopefully that gave us a little bit of understanding. We went through that rather quickly, but if anyone has any type of questions, if they could type them into the question segment, the question portion on the GoToMeeting toolbar. Okay, anybody in here have any questions? Yep.
Yeah, you mentioned that the instrument light should be a pulsating flow.
Yeah, the operation of it with that well, let me repeat the question for everyone online real quick. The question was, why does the unit want to see a pulsing type flow? And the best I can answer that is it wants to see that flow pulsing, and then that triggers that ultrasonic signal in both directions. So that pulse starts, it triggers the ultrasonic signal, and then it measures the flow going through. It's all in the timing of it, I guess. But you have to accept that. Don't want to see it.
Would it work with a laminar flow?
No, it will not work with a laminar flow. So it does need that pulse. We do have some questions online. Will there be Dulcoflow for Sigma units? And we don't know the answer to that. We'll try to find out if there's any plans for that, and maybe announce that on a future webinar if we're able to find that out. We just don't know. We're not part of the development process here, but Germany always likes to have us with the best technologies around. So if there's a way they can do it, I'm sure that they will get it over to the Sigmas. Maybe they wanted to release the Sigma Bs first, and now to work on a way to match the Dulcoflow with the Sigmas. Don't know that, that's speculation, but we'll try to find out an answer for the future. What is the viscosity the Dulcoflow can handle? That's a very good question. That I know of, it can go up to about 200 centivolts. I'll try to verify that for you, John. But it doesn't handle highly viscous. It can have something with some abrasives in it, some larger particles going through it, because there's nothing really blocking the flow going through the device, so it will handle that fairly well. It may miss that stroke if it's going back to a counter, if it has a particle through it. The other thing that we have to watch going through it is air. Air does not transmit that ultrasonic signal properly. So gas, vapors going through the unit, which includes bleach. We have to be sure that any gas that is formed in the bleach is handled before it gets to the Dulcoflow unit. And so if it's bleach, it almost has to be a suction lift with a auto degassing liquid in. That would probably be the best way to eliminate any gas getting into the discharge line. Any other? We have one other question here. Does the Dulcoflow need to be connected to the pump to offer a 4 to 20 output signal on the flow unit, or can a customer connect up directly to the flow unit and bypass the pump to get the output signal? Depending on that option that we pick, let's try to go back here. I'm going to exit out of the camera. Hopefully everyone can see this. Depending on what option we pick here would be whether that 4 to 20 is going back to the pump. Option 4 is feeding it back to the pump. That's feeding it back to a Delta pump specifically with the control module. If we get the current output, option 1 here, or option 3, current output plus the counter output, that 4 to 20 signal going out is just a 4 to 20 signal. It's just intended to go to the customer. Whether they want it for a remote display, out to a chart recorder, whatever they're using that 4 to 20 signal for, that is a powered loop going out. And I believe it can drive up to, I think I saw 400 ohms. If that's a question, how much can it drive? We want to verify that. I'm thinking that I saw it was 400 ohms, but